Today we're going to look at functions and relations. More functions than relations. We've been looking at function characteristics. Now we're going to look at how we can add, subtract, multiply, and substitute functions inside of other functions and see what happens. So we're going to start by just talking about a general relation. A general relation is any set of ordered pairs. It does not have to have any specific relationship to it at all. A function is a relation, in other words, a set of ordered pairs, such that every single input, which we'll call an x value, has exactly one output, which we'll call a y value. Let's take a look at these two examples. Right, so let's take a look at these two examples. In the first example, what we want to see is that the x values don't repeat. So here you have a 5, 2, and a 5, 4. So since the x values are repeating themselves, what we have is just a relation. This is just a relation. It's a set of ordered pairs. In this case, the input, the 5, has two separate outputs. So what that does is it disqualifies it from being a function. But on the second example, you'll notice that 1, 2, 3, 4, and 5 are all unique. And therefore, each input only has a single output, which makes this a function. So we don't want the x values to repeat. The y values, we're not worried about the y values at all. We're only concerned with the x values. Each input, the x, has to have a specific output. So that's an example of a relation and an example of a function. All right, function notation is just a fancy way to write equations. All right, so the function notation replaces the letter y with the symbol this, which we've actually probably already seen if you've been paying attention on the previous pages, to show that an equation represents now a function. Not just an equation, but now it's a function. So in other words, its inputs are unique. It's actually pronounced f of x. So that green symbol here is pronounced f of x. So I guess you could say that the parentheses is the letter of, or the word of. So it's f of x. So we can take the equation that's underneath that, and we can write it now as f of x equals 2x plus 4. So instead of the y being there, the y got replaced with f of x. So when we evaluate functions, it also shows the relationship between the x values and the y values. And what they are is it becomes an ordered pair, x, y. So when we evaluate f of x equals 2x plus 4, what you're doing is you're taking the 2, which is an x value, you're inputting it into the equation, and it gives you the y value. So it's input output. So that's 2 times 2 plus 4 plus 4 plus 4, which equals 8. And we've got an ordered pair, 2, 8. Next is going to be combining functions. Now this is going to be a lot like what we've already done with polynomial functions. So in this section, we will basically be adding, subtracting, here's a little bit more adding, some multiplying, and then evaluating with a number. So here you'll see there's a number inside the parentheses. And then again, there's some evaluating with some multiplication. Okay? So I'll show you a few of these examples. Let's clear that page. Alright, so this first example, example 1, says that we're going to take the f function, which is here, 6x squared minus 3x plus 5, and we're going to add to it the g function, which is here, the g function. So really, this is just polynomial addition, which was what we did at the beginning of this unit. 4x squared plus 5x minus 8. We're going to combine like terms, write it in standard form, and that's all we do for the addition of that polynomial, or these two functions. So that is 10x squared plus 2x minus 3, and that is the combining using addition of functions. Subtraction is going to be very similar. You just have to pay attention to which function comes first. So the g function is first over here, 4x squared plus 5x minus 8. Then we will subtract the f function, which is 6x squared minus 3x plus 5. But since this is a subtraction problem, the signs change behind it. And now again, we combine like terms. So we are at negative 2x squared plus 8x minus 13. And that's addition and subtraction, just straightforward. Now when you look at example 2, it has a 2 in front of the f function and a 3 in front of the g function. So those are acting as coefficients to multiply the f function by 2 and then multiply the g function by 3 and then add them together. So as we do this second example, I'm going to multiply the g and the f functions by 2 and 3 respectively as I'm writing them down. So the f function, which will be green, will be 12x squared minus 2x plus 6. We will add 3 times the g function. So that would be 3x squared plus 9x. And now we add them together just like we did previously. 15x squared plus 7x plus 6. And that's the combining of those two with coefficients. Example 3 is a multiplication problem. So it is the g function, g, which is right here, x squared minus 3 times the f function, 2x minus 4, and we just multiply, we FOIL. We do the same thing we've done in multiplication. So x squared times 2x is 2x to the third. X squared times negative 4 is negative 4x squared. Negative 3 times 2x is negative 6x. And negative 3 times negative 4 is positive 12. And there's nothing to combine here because everything is unlike terms. And it's already in standard form. As we multiplied it, that's just happened on its own. The last two examples, down here on the bottom, take numbers 3 and it plugs it into the f function. So you're going to put a 3 here, you're going to put a 3 there, and then it takes the 3 and puts it inside the g function, 3 and 3, and you do those operations, and then finally, at the end of the problem, you'll add those numbers together. So let's take a look at that. So the f function, which I will continue to use blue, is 4 times something squared minus 2 times something plus 5. That something happens to be a 3. So we're plugging in 3. So let me go ahead and do that. This evaluation comes out to be 35. Okay, so when we plug the 3 into the f function, we get 35. All right, then we go to the green. I'll do G in green. I did F in blue. I've done that the entire page. So we've got, supposed to be green, something squared plus 7 times something minus 8. That something, again, is a 3. So that 3 is placed into the parentheses. We'll do this. This comes out to be 22. And the problem says that we're supposed to add these values together. So we will add them together, and together that gives us 57. So that's the 4A example. Now I kind of used too much room, so I don't have a whole lot to do my B problem. So let me squeeze that down. All right, magic happened while you guys were gone, and that magically just shrunk. All right, so now I have room for my B problem. And I'll try to write this a little bit smaller. All right, so B problem takes the G function, G, multiplies it by 4, and inserts a 2. So it's going to look something like this. Negative 4 parentheses squared minus, so that's plus. Oh, so I just noticed I'm not supposed to have a negative on that 4. So 4x squared plus 28 times x minus 4 times 8 is 32. All right, then inside those parentheses, we're going to put a 2, a negative 2. So negative 2 here, a negative 2 there. Let's calculate what that is. All right, so that is negative 72. The next part of the problem just is f. We're not doing anything to the f. Notice there's no number in front of f that we need to multiply or distribute with. So we'll just use the f function, which is 4 times something minus 2 times something plus 5. That something that we're inserting is negative 2. So put negative 2 in, negative 2 in, and we'll calculate that, which comes out to be 25. And then the problem says we want to multiply those two values together. So we're multiplying negative 72 times 25. And yeah, I wouldn't do that by hand. So make sure you have your calculator out. Times negative 72, which gives us negative 1,800. So that is combining functions. The next step of functions is composing them. And what composing is basically substitution. So this is going to be the tougher part. So what we just did was adding, subtracting, multiplying. So that should be something that you were familiar with, but this is going to be something new. So function composition is applying the rule of one function to another. Okay? So this symbol right here is read kind of like it was earlier, but now there's just more to it. So it's read f of g of x. So you're reading it from the outside in. So you're reading it just across, just like you would read a graph yesterday from left to right. So that's read f of g of x. You'll notice that g of x, right here, g of x, is the input. It's inside, okay? It is inside the parentheses. So that is what gets input. Oops, I spelled that wrong. It's inside the parentheses. So we're going to substitute the g into the rule of x, okay? And then we simplify it. So basically, it kind of looks like this. You got two functions. You got an f function, which we've been using blue, and you have a g function, which we've been using green. Okay, so you have two functions. And so f of g of x is going to take the g function and put it inside of the x of the other function. Remember that we're talking about substitution here. So we're substituting, we're replacing one function inside the other function. So let's read what it says down here. Fill in some blanks. F is the outside function. And G is the inside function. We're going to substitute G. G goes into the f function. So if you notice, below this, right in here, the f function is written down. It's 2, and then they opened up a parentheses, and then plus 5. Plus 5. So they opened up a parentheses so that the g function can go inside of that parentheses. So we're actually going to put it in there. So we're going to get rid of that. And as you see, what I did, hopefully you see, what I did here, I'm putting it inside of where the variable is. So we're going to take the g function, which is x minus 10, and put it in the parentheses. And then we let the math happen. We let simplification take over. So here is where PEMDAS comes in. We multiply. Let's see, there's nothing to do inside the parentheses. There are no exponents. So we multiply. We take the 2, we multiply, 2x minus 20. The 5 gets brought down. And the final version of this is 2x minus 15. Pay attention to the order of the functions to know which one goes inside the other one. The inside function, the g of x, is inside the parentheses, so therefore it goes into the f function. Let's look at some more examples of composition of functions. Now, this example, this page, has 4 different functions. So we've been using blue for the f, green for g, but now we have 2 other functions. We have an h function, and I need another color, So I guess we'll just use red. We have J as the J function we'll use for red. So we have 4 different functions. So you really got to pay attention to what the problem says. So the inside function goes into the outside function. So the way I start that is like this. I use outside, and then you put the parentheses and you put the inside function there. So with the problem number 1, you'll see that it is G on the outside, so that's going to be green, 3, parentheses where the X is, minus 8. And then for the number 1 problem, it puts F on the inside. So F is the blue function, so that's going to be X squared plus 2. And then we simplify. So we multiply by the 3, 3x squared plus 6, bring the negative 8 down, so we've got 3x squared minus 2 as a final composition. On the number 2 problem, H is on the inside and G is on the outside. So we're going to use the G function again, 3, parentheses, minus 8. This time, we're using the H function to put on the inside. It's negative 2x squared plus 1. Again, we apply the 3. We multiply negative 6x squared plus 3. Bring the negative 8 into the problem. Negative 6x squared minus 5 is our final version. For the 3 problem, this uses the F on the outside, which is something squared plus 2. And then the G is on the inside. So we put 3x minus 8 on the inside of that problem. Now the problem here is we have to FOIL. You're not allowed to just square the 3x and square the 8. Okay? So I'm going to do this kind of quick. This is 9. I'll use blue, I'm sorry. 9x squared minus 48x plus 64. That's the FOILing. So if you need to, write it out twice, FOIL it out. Multiply 3x times 3x, 3x times negative 8, etc., etc. Bring the 2 back into the problem and finish it up. 9x squared minus 48x plus 66. And I want to show you problem number 4 because it takes the J function and puts it inside the J function. So you can put a function into itself. So the outside function is J, that is 4 times minus 3. We'll put the J function, which is the same function, into itself and apply what's going on. So we'll multiply the 4, which is 16x minus 12 minus 3, which gives us a final 16x minus 15. Okay, so I want to show you the last 3 examples, which are F, G, and H. And these are going to require your calculator. So the previous examples, like E and all the ones before it, they all have this X hanging out in the middle of the problem. So the X just went into the H. Well, if you look at the H function, there's H already there. I'm sorry, X already there. So what's different about these these last three examples is that they have a number there instead. And so remember that this is all substitution, okay? So we're going to take this 2, and we're going to substitute it into j, and then substitute that value into g. So we're going to take the 2 and plug it into the j function. Notice j is red, so it's 4 times minus 3. So that's your j function, which we're going to put a 2 into, and you're going to calculate that and get a number. So 4 times 2 is 8. 8 minus 3 is 5. So what we just found is a value that is now going to be put into the g function. And so that is 5. We're going to take 5 and put it into the g function. So the g function is 3 times something minus 8. And we're going to put 5 in there. So what we did is we took the value that we found from the first calculation and put it into the second equation. Make a calculation out of that, and that's going to be your final answer. 3 times 5 is 15, minus 8 is 7. That is our evaluation. The next example, G, uses the g function twice. So the g function is green. 3 times something minus 8. So we're going to take the 3 right here, negative 3, we're going to plug it into the equation. We're going to get a value out of that. 3 times negative 3 is negative 9. Negative 9 minus 8 is negative 17. We're going to take that value and we're going to plug it into the g function again. So we take 3 times, this is the g function, this 17, negative 17, is going to enter back into the problem. Now I'm going to need my calculator for this one, so bear with me for just a second. 3 times negative 17 minus 8 is negative 59. Negative 59, and that is our final evaluation. Lastly, the H problem takes the negative 4 and plugs it into J. The J function is red. 4 minus 3. We take negative 4, plug it in there. 4 times negative 4 is negative 16. Negative 16 take away 3 is negative 19. We take that value that we just found, and we're going to go plug it into the F function. The F function is blue, so it's something squared plus 2. So we take our 19, our negative 19 that we found, and we plug it in there. Negative 19. Negative 19 squared plus 2 gives me 363, and that is our final composition.